So, how do we think where things are? To answer this, we utilize a coordinate system, a universally agreed upon reference that allows for the precise identification of locations by both humans and machines. This system, and that's why I have this map open, is akin to a city grid where streets and house numbers offer an exact positioning relative to a known origin, enabling global positioning on a planet, but enabling this on a planetary scale. And Philadelphia is a great example for that. As Philadelphia, we have north and south component of on many addresses, and the origin or the difference is given by city center. We know that everything north from City Hall is north, everything south from City Hall is south, and the street numbers start to increase from the Delaware River to the west. So just knowing that an address is North 18th Street, we know that we are all roughly 18 streets from the riverfront and on the north of City Hall. Um, and in this order of ideas, global positions are determined by their position to the Earth in the Earth grid. And just like as a point in a Cartesian plane that can identify through the combination of its two values x and y, for example here, find out f around. So the combination of two unique values in the x and epsilon value axis gives us a specific location, and we can move all the way in the find out or in the f around axis. Anyway, um, this concept is not only used here, but it's also used very common in board games like Naval Battle, but also in video games such as Minecraft. You know that it employs a coordinate system XYZ because it moves in a three-dimensional space to specify locations between the digital landscape of Minecraft. So of course, this is covers a very reduced area, and the global grid looks like this. This is actually Google Earth Pro. I really recommend you to download this software. It's free. I am sure that it's installed in most of the computers that are available on campus, but if not, just download it. It will be very useful and very fun to use, and it costs nothing, and you just need a Google account. So, uh, not only the size is different, but also um, um, we are not working on a plane like a city, which is relatively plain, or a flat surface, but we are on a sphere. And instead of x and y axis, we talk about latitude and longitude. Latitude are the distances here towards south and north, and longitude are west and east. Um, and, and because we are in a sphere, the units are expressed in degrees. 360 degrees are in a sphere, 180 degrees are half a sphere. Um, the lines that go from south to north are called meridians, and they all meet here and on the north and the south pole. They cross here, while the lines to go from west to the east are called parallels, and they actually never met. The, the meridians are always the same length, but the parallels become shorter when you go towards the sun and towards the south. And those are the streets and avenues of the earth. Of course, they are not exist. They are a theoretical construct, but this is the way it has been. This has been established. And just as Philadelphia, where we have City Hall as the origin and the river, the Delaware River as the origin, we also have two origins, which are the main two of the main streets of the Earth. The equator here that divides the Earth into halves, the northern and the southern hemisphere, and the prime meridian also, which is here, this yellow line here, that is also called the Greenwich Meridian, if you have already heard that, because it crosses through the Royal Observatory of Greenwich in London in the United Kingdom. There are historical and political reasons why 25 countries in the late 1800s had a conference and decided to that this would be the reference meridian, and that's how the whole world ended up adopting it. Um, so these lines divide the planet in hemispheres. Hemi, of course, is from semi, from half, and sphere is from sphere. So we have two hemispheres, the northern and the south, and we have a western hemisphere, which is everything that is west from the prime meridian, and an eastern hemisphere that is everything that is to the east of this meridian. Of, of course, there's the prime meridian, there's the anti-meridian, which is exactly the other side. And see how the numbers here come from 0 here 280 because it's half a sphere. So we have the Earth divided in 4 quarters. We can be in the northern hemisphere and on the eastern hemisphere, which is basically most of Asia, uh, Central and Eastern Europe, and a large chunk of Africa. Then the northern western hemisphere includes all of North America, a small part of Western Europe, this corner in Africa, and up to the northern part of South America. Actually, the country of Ecuador, of course, gets its name because the equator crosses it. And don't pay a lot of attention here. This is part of my research. Anyway, so we have these four hemispheres: the south hemisphere and the western hemisphere, northern hemisphere, and west, um, north and east, and south and east. That includes basically Oceania and the southern tip of Africa. So, and of course, the distances are expressed in degrees, and when we come closer, we see how we can have like a little bit more of detail. But let's go to Philadelphia to make an example here. So, for example, Philadelphia, if we go here, I put this pink marker here. If you see in the lower right corner of your screens, you will see some numbers moving here. If I go to Philadelphia, it's 39 degrees, 57, and 75 degrees, 35 degrees north and 75 degrees west. That means that Philadelphia is between 40 and 75, 40 degrees north, 75 west. And we can see all of this for all the cities that we assign. Asheville around 3582, Nashville 3686, Austin 3097. See, as we move towards the west, the number increases, and we move towards the north, the other number increases. And finally, San Diego, which is in 117 degrees. If we get to the antemeridian, we are not in the west anymore, but we are on the east. This is where the international date line is not exactly here, but very close, which is where one day ends and the next one starts. Um, so using this grid, so we have like here the main streets, the two tropics, which define the tropical area from the subtropical and temperate parts of the world, the Arctic Circle, which is here around 65 degrees, 60 something degrees. Those are the main streets, and that's how you can really locate yourself. But we can go as close as we want, and you will see that the grid becomes finer and finer and shows the specific location. And those are, this is how each coordinate on Earth is expressed. All the places on Earth have a specific coordinate that identifies it. Um, so it is also important to keep in mind that the coordinate systems can be expressed in two ways. Here, this weird way is degrees, minutes, and seconds, and fractions of seconds. In a degree, there are 60 minutes and 3600 seconds. Um, this is a system that is kind of older and more traditional and is used for historical reasons. It's more closer to um, the way we humans conceptualize space, but and is also the result of the instruments where this first system was created and where distances and locations were determined. That was through the observation of the stars and other phenomena using calculating the angle, which was done with analogical devices that work in these units of distance in these units of minutes and seconds. However, and it looks very nice, and you will see always in the design and in stickers and in accessories, always this system be used. And you have like the minutes, seconds, and degrees, minutes, and seconds, and north and west. If we move to other parts of the world, we would go to the south, and you see that here the coordinates became south in Peru. But this system is kind of complicated and is a little bit outdated because it's more complicated for machines to process. It requires more more processing power and makes the things a little bit more difficult. That's why this was changed for this is changed for digital applications for with this is replaced with a decimal degree system. Of course, there are ways to transform between one and the other, and this is one of the exercises that you will do in this class. I provided for this week, I provided the formula, and there is a video that also explains that. But those are two ways to express the same thing. Um, so as And in this second system of degrees, decimal degrees, we don't speak about north and west, but we provide positive and negative values. So here, and I forgot to mention that, where this is the origin of the reference system in the world. This is kind of the city hall of the world. It's a place called Null Island, which actually doesn't exist. It's in the Atlantic Ocean, around 600 kilometers. That means 400 miles off the coast of the country of Ghana. And this is where the prime meridian and the equator meet, and there is just a buoy, and all the distances are in relationship to this, all the locations are in relationship to their distance to the origin, to the zero point or null island. Um, and in these four squares, this is always considered positive, what is like in the normal coordinate system, whatever is to the right and to the top of the origin is positive, positive. Here we have positive but negative because we are in the southern hemisphere. Here we have positive, negative, northern hemisphere and western hemisphere, and here is negative, negative. And this is when you see these numbers or these prefixes, you will know exactly where you are. It's like if you know if you're in North Philadelphia or South Philadelphia. This is the same principle here. Um, and this is an explanation of how the we as humans and as society have agreed upon a system to identify and locate each place on Earth. And when your phone determines your location using the GPS, it will express its position in terms of this reference system. And this is something that you need to keep in mind for your assignment. Okay,